Hi students, and welcome to Science Extension and Module 1, The Foundations of Scientific Thinking. This is video number 8, and we're looking at ancient cultural knowledge. In our previous video, we looked at Aboriginal and Torres Strait Islander culture and heritage and the way that they have been doing science for millennia. We're now going to move on to some historical examples to evaluate the contribution of cultural observational knowledge and its relationship to science, but this time we're going to look at some pre-1500 Common Era exemplified by the Greek and Egyptian cultures, as well as some of those from the Asian region. So I will cover a few things here. I think this is very important that you explore each of these in a little bit of detail. Some of the knowledge that was constructed by the Greek philosophers as a characteristic of Greek culture. In Egypt and the Middle East, we had a lot of ancient calendars, a lot of astronomy, and particularly in the Middle East, a focus on mathematics and medicine, as well as some of the early technologies that were developed in Asian cultures. To help me prepare for some of this particular focus area, I've had a look at Jim Al-Khalili's Pathfinders. It's a really interesting book and lots of information that I wasn't aware of as I read through that book, and it's very readable as well as a few other sources just to try and understand some of the links between ancient culture and early science. I guess one of the keys when you're looking at ancient science is the focus on philosophical, theoretical, and observational knowledge. These have been around for thousands of years, and we know something about the contributions from ancient Greece, from the Middle East, from North Africa, and also from Asia. This is just a little map that you can see where a lot of the ancient astronomical knowledge has been pinpointed on this particular map. And whilst you can see a large amount in Western Europe, you can also see it scattered through the Americas and Asia. So let's first have a little bit of a think about the ancient Greek science. And I guess when you're looking at ancient Greek science, you're going to be looking at a couple of very important philosophers. That might include people like Aristotle and his contribution to the field of logic. We talked about deductive reasoning earlier on, and he was the founder, or credited as being the founder, of deductive reasoning. We can think about Archimedes and his contribution to many simple machines like the Archimedes spiral. We also, in astronomy, look at Ptolemy's epicycles and how his epicycles help to explain the geocentric universe, that is, the Earth at the center. And also we see some early ideas about the sun as the center from philosophers like Aristarchus. The fact is that the ancient Greeks produced many key thinkers in science and philosophy. The essence of their approach was to seek explanations for things they'd observed in nature, including the motions of the planets. Greek astronomy was influenced by the Babylonians, the Chaldeans, and the Egyptian civilizations, all of whom made major strides in astronomy. I mean, everyone looks up. Greek astronomers employed principles of physics, both including parallax and mathematical geometry, to develop explanations for astronomical phenomena, and also conducted some very simple experiments to try and confirm some of their ideas. Aristotle developed the geocentric model. The model was the predominant model of the solar system until about the 16th century. The heliocentric model, which replaced the geocentric model, was also developed in the 3rd century before the Common Era in ancient Greece by the astronomer Aristarchus. He was also able to measure the curvature of the Earth and calculate the size of the Earth and the distance between the Earth and the Moon. Most modern astronomy is still based on some of that early Greek astronomy. Ptolemy's contribution to astronomy, the geocentric theory, and the epicycles was part of mainstream thinking for many centuries. His work was translated into Arabic and was called the Almagest, or the Great Work. When we think about Middle Eastern science, it's probably the easiest thing to do is just to pick out some highlights. It's a very, very rich culture and way too much for us to include on a single video. So it's really important to go through and have a look at some of these very important areas that aren't always discussed as often in Western science. But in the 9th century, The Abbasid Caliph of Baghdad, Abu Ja'far Abdullah al-Mamun, created the greatest center of learning that the world has ever seen, and it was known as the Bat al-Hikmah, the House of Wisdom. The scientists and philosophers he brought together sparked a period of extraordinary discovery in every field imaginable, launching a golden age of Arabic science. And these are the words of Jim al-Khalili in his book Pathfinders. Included in those luminaries is Abu Rayyan al-Biruni, a polymath who outshines everyone in history with the possible exception of Leonardo da Vinci. Syrian astronomer Ibn al-Shatir, whose manuscripts would inspire Copernicus' heliocentric model of the solar system. The 13th century Andalusian physician Ibn al-Nafis, who correctly described blood circulation 400 years before William Harvey. Iraqi Ibn al-Haytham, who practiced the modern scientific method 700 years before Bacon and Descartes, and founded the field of modern optics before Newton. And 19th century zoologist Al-Jahith, who developed a theory of natural selection 1,000 years before Darwin. When we look at the great contributions to Middle Eastern science, we often are talking about names that we're unfamiliar with and some very important theories that we may never have heard of. And yet a lot of this work was happening well before the more established Western science came to, I guess, more popular ear. Islamic science flourished between the 7th and 15th centuries when European centers of learning were in decline. Islamic science were beneficiaries of scientific knowledge from many parts of the world, including India, Europe, and other Middle Eastern nations. The Islamic world produced several leading scientific thinkers, including Gerber, a Persian chemist, astronomer, engineer, geographer, philosopher, physicist, pharmacist, and physician. Avicenna, Persian astronomer and physician. Raziz, Persian polymath, physician, alchemist, and philosopher. Alhazen, Iraqi mathematician, astronomer, and physicist. And Al-Khwarizmi, Persian mathematician, astronomer, and geographer. Many of the discoveries of these scientists were translated into European languages and simulated scientific discoveries in the West. As Islamic rulers invaded countries from the Far East to Europe, they were absorbing local knowledge about science, medicine, philosophy, and technology, and books from Greek and Roman civilizations were translated into Arabic. Scholars examined reasoning and logic, particularly empiricism, as well as experimental science. Islamic medicine was based on the words of the founder of Islam, "Make use of medical treatments, for Allah has not made a disease without appointing a remedy for it, except for one disease, old age." Another area we can look at around the Middle East is Egyptian science. And again, there's some really interesting discoveries or records that we have of some Egyptian science that was happening. The development of a ship sail using principles of aerodynamics, later net forces to determine that a ship could be sailed with side winds. The use of papyrus to record scientific observations and thoughts, and the Nabta Playa calendar at Aswan, where astronomical features were used as a solar calendar. Ancient Egyptian astronomy was closely related to the religious and cultural practices of its people. It's thought that after some of their star maps were developed to guide the journey of the spirits of the dead in their passage to the afterlife, the calendars were developed to schedule religious festivals and temple activities. The Egyptian calendar was the basis of the Gregorian calendar, which is still in use today. Some of the features of Egyptian astronomy included being able to tell the time at night. Groups of stars called decans were used for telling the time in the evening. Each group of stars rose 40 minutes later each night. Observing the position of a group of stars relative to the day of the year would tell you what time it was. They also developed an annual calendar. Ancient Egypt's calendar had 13 months because the 12 lunar months were not enough to make up a whole year. So when the constellation of Sirius rose very late in the 12th month, the 13th month began. And also the pyramids themselves. The east and western sides run almost due north, and their southern and northern sides run almost due west. This kind of positioning could only have been done through the use of astronomy to find north and south. And Asian science. The Han rice paddy farms and the seismograph, the development of a compass, overlaps that we see in the areas of maths, astronomy, and again, medicine. State-sponsored R&D produced engineering and technologies including metallurgy, gunpowder, printing, paper, and irrigation. And traditional Chinese medicine is probably very well known and views the human being as an existing in a harmonious relationship with its natural environment. Some techniques in pharmacology, herbal medicine, and acupuncture have survived from the Ming Dynasty. Many Asian cultures also made significant contributions to scientific understandings, and while their inquiry approaches were not driven by the philosophical underpinnings of Western science, Asian scientists sought to explain natural phenomena in similar conceptual frameworks. Historically, science in China was viewed from a practical perspective and to manage their large population. Many of their scientific discoveries were state-sponsored research and development that led to the development of various engineering and technological feats. Compared to Western science, Chinese science didn't focus on systems of reasoning and logic. Li Xinzhen gathered medical information from cultural observational knowledge from across China, and he spent over 30 years writing his book of the Compendium of Materia Medica. The Compendium, a medical text including 1,100 illustrations and 11,000 prescriptions, set the foundation for Chinese medicine. The discovery of artemisinin for the treatment of malaria was also described in ancient Asian culture. So what can we conclude from all of this? Well, science is the product of our innate sense of curiosity and our quest for meaning. Everyone has looked around and asked questions of the world around them. Modern science is descended from many different philosophical traditions. Scientists employ various approaches to investigate and construct explanations of natural phenomena. And no matter what those approaches may be, scientific investigations are united by the need for evidence, logical reasoning, and peer evaluation. Scientific research involves extended periods of purposeful investigations conducted in the relentless pursuit of answers to questions. Each discovery or solution spawns numerous other questions, giving rise to a self-perpetuating cycle of inquiry. While science is not the sole route of acquiring meaning, history shows that scientific knowledge has been a powerful force for shaping the evolution of human societies. And a very significant thank you to the Department of Education for a lot of work that has contributed to this video in the preparation of resource material for the Science Extension course. Thanks for watching.